Bowling alleys typically spend over $100,000 per year in electricity. Many bowling alleys on Long Island operate their lanes with inefficient motors from the 1950s. Currently, this is Bow Long Island at Patchogue's situation. When the lanes are activated, the pin setting motors are constantly running even when they're not in use. Our plan is to devise a cost-effective method for older bowling alleys to operate their lanes, saving energy and money without the need for complete renovation.
Our design aims to better control the activation of the pin setting motor in order to avoid unnecessary losses in energy usually associated with the continuous operation of the lane. The design consists of three main parts: the relay circuitry, the timing circuitry, and the sensors. We'll now explain in detail each aspect of the design and how all three aspects work to control the pin setting motor more efficiently.
Relays allow circuits to be switched by electrical components. In our case, the relay interfaces with our timing device and when activated connects our timing circuitry to the existing bowling alley wiring. The Darlington transistor connects the 555 timer to the relay circuitry, energizing the relay. When the relay is energized, the contacts close and the connection is completed to the bowling alley wiring. We install the switch that overrides the project in case the bowling alley does not want to use our device or in case something malfunctions. At the bowling alley, there is no existing switch that we could tap into to override the pinwheel motor. Instead, we had to tap into the wiring where the motor gets power and install a new switch.
The next step for us was to mount the project box with the timing circuitry in the back of the lane. The project box is detachable, so our design can be easily removed in order for easy maintenance. We also mounted the project box with tape in order to be easily detached for maintenance as well. We labeled the switch so that the bowling alley mechanics can safely operate our device with no confusion.
Next, we mounted the laser diode along with the IR receiver. We needed to make sure that the laser and receiver matched up exactly. To ensure that the receiver and laser diode were properly aligned, we used clay to mount the components. This allowed us to temporarily test the system to ensure our device worked properly before permanent installation. The laser diode had to be embedded deep enough into the wood so that the beam is not seen by the bowler, causing a potential distraction. Once the device was working successfully, we drilled the holes for our sensors into the wood on sides of the lanes. The laser diode and IR receiver were then permanently soldered to the wires coming from the back of the alley and embedded just underneath the kickback out of the side of the bowlers.
The variable resistor sets the time at which the device will shut off the motor after inactivity. We can change this time to optimize our device's efficiency. Setting the resistance higher means that the device will shut off after a longer period of time and vice versa. The 555 timer consists of a trigger pin that triggers the system to turn on the motor. The threshold pin and discharge pin are connected to the capacitor, which fills with charge as time passes. The output pin of the 555 timer is connected to the relay circuitry. The capacitor connected to the timer fills with charge until a set time, determined by the variable resistor, and then discharges, shutting off the system.
The Arduino was coded to read the output voltage, either a low or high, when the motor is turned on or off. Low voltage means the pin setting motor was off, and high voltage means it was turned on. Every 5 seconds, the Arduino takes note of the voltage and saves the data into an SD card. With this information, we can determine how long our device shuts the motor off for when the motor would have otherwise been on.
So as you see here, the pinwheel is off while the lane is not in use. Then, when a bowler throws a shot that passes the sensor mounted on the lane, the pinwheel motor is activated. The pinwheel motor will constantly run if the sensor is continuously triggered. If the sensor is not triggered after 1 minute of the previous throw, the pinwheel motor will automatically shut off, resulting in energy and money saved.
Potential problems that need to be considered are: need to determine if there are false triggers from light or sound, need to ensure that the movement of the laser diode does not occur after permanent installation with silicone glue. For long term, we need to assess if the laser diode and IR receiver are being damaged by bowling balls, pins, or people. Overall need to mainstream the setup of our device in the back of the bowling alley to protect it from damage and misuse. Assessment of the overall lifespan of our device.